We're now going to look at how the shape of the histogram creates a different shape. And these shapes are really important because they will affect things later that we do. And we want to be able to recognize if a histogram has a shape when we look at the histogram. So we have four main shapes that we're going to look at. This does not mean that these are the only four shapes that are out in existence. These are just the four that are mostly talked about and that we're going to talk about in the scope of this course. The first one is a uniform distribution. This is where all of the frequencies are the same or almost the same. They could be off by like a tiny amount, but it's pretty much all the same. These are fairly rare, I would say. We see them more so when we're looking at probability. So examples are outcomes when rolling a die, what suit you might get when you're drawing a card. The example graph I have here is the minutes it took to finish a quiz and how many students. I don't know that that would really be uniform, possibly depending on the quiz and the class. But as you can see, the height of all of the bars is the same. If I draw a line over it, I can draw a nice straight line over the top. The second shape is a bell-shaped distribution. This one is very common. You are going to become BFFs with this distribution throughout the course of this class. So a bell-shaped distribution occurs when the highest frequency is in the middle of the graph, and then the frequencies tail off to the left and the right in roughly equal proportions. This distribution is symmetric, so that means if I fold it in half, it'll line up on either side. It's like a mirror image of itself. So if I draw a line over this one, we get kind of a bell shape to it. It's like a Taco Bell. So some examples of things that are bell-shaped are height, birth weight, SAT scores, IQ scores, a lot of things in probability are bell-shaped. It's a very common distribution. Okay, like I said, we're going to be BFFs with this distribution. You just wait. Another type of distribution that we see pretty frequently is a skewed right distribution. So in this distribution, the highest frequency occurs to the left of the middle, and then the graph ends up with a long right tail. So if I draw a picture over this one, notice this long right tail. That is where the skewed right comes from. These graphs are also referred to as positively skewed. So some examples of things that could be skewed right are the speed people are going when they get a speeding ticket. Most people are going like 10 to 30 miles an hour over the speed limit when they get pulled over. And then you have those few people that are like, ooh, the new express lane on I-70 was made for me to go really, really fast. And I'm going to go 80 miles over the speed limit. Maybe that's just a me problem because of where I live. But you don't have too many of those people. So most of the speeds are clumped together down at the lower ends, and then you have those few speed racers that are up at the higher ends, but they're few and far between. Other examples are wealth and household size. The other end to that is a skewed left distribution. So in a skewed left distribution, the highest frequency is on the right side of the middle, and the tail is on the left. We have a long left tail. So some examples of, actually, let me write this out here too. Let's see, long left tail. And these are also known as negatively skewed. So examples, this graph is showing test scores. For the most part, we would love to have tests where most of the students are doing really well, and then you might have a couple of students that didn't study, haven't been coming to class, and they just showed up on the test day. And so those are the really low scores. But we want, this is what we want. We want all of our students to be getting, you know, B's and A's and ooh, look, even over 100%. Get those extra credit points. Woo woo. Okay, and then just, a few students not doing so well. Okay, get those students up here, and then we won't have a skew. It would be beautiful. This is what we see in some of our classes. Other examples are retirement age. Most people retire when they're older. Very few people retire when they're younger. And human lifespan. Similar sort of thing. Most people die when they're older. Very few die when they're younger. So these are our distributions, the different shapes of them, and the types of data that you could see for the different types of distributions.